Okay, so let's begin our new week by basically digging deeper into our definition of our trig functions. Again, I playfully call this our x, y, r definition. It's our first definition for our trig functions, and what we're going to basically be doing in section 1.4 is take that information and build new thoughts, if you will. Build on it. This is very similar to what we did in our review a couple weeks ago when there's concrete function questions, and then there's abstract ones where we actually, build on given information, we build new ideas from that information. So that's kind of what happens here. We now have a definition, we know how it works, and so that basically sets forward some problems we can do and some new ideas that we can build on. And these ideas will be very, very important for later on for graphing and solving equations and everything else. So please make sure you're paying attention. The first thing that we're going to do in 1.4 is what I think is pretty straightforward. This is probably the most straightforward as it's going to get. And so what we're going to basically do is we're going to use our trig definitions to help us find missing trig function values when we're given something else. All right, so for example, in this first one, we're being asked to find the sine of theta. Now again, let's just make a mental note here. What do we know about the sine of theta? Well, by its definition, it's y over r. All right, so we got to find the sine of theta, right, given that the cosecant of theta is 3 over 2 and theta is in quad 1. So basically, all we really need to do, since we are using an x, y, r definition, we need to figure out what x is, what y is, and what r is. If I can figure that all out, then we're off to the races. I just plug in what I need to know, and I got it. So what do we know about cosecant? Well, we know about cosecant of theta is that it's actually r over y. So if we set it equal to what it's equal to right now, 3/2, we have a pretty good direct idea of what's going on. We know that y is equal to 2 and r is equal to 3. And I don't really need to know what x is, right? Because when I look what I'm looking for, the sine of theta is just y over r. So basically we're done, right? So for this particular information, my y is 2, my r is 3, and we're finished. All right, some of you probably have already kind of seen or are aware of the fact that these guys are reciprocals of each other, and we could have just gotten there right away. But more on that later. I'm kind of getting into some trig identities. But that's going to be kind of our MO for this first round. So there's enough information, right, about what y is and what r is or what x is. We take that information to build what our function we're trying to find. So this one was kind of easy because the y and the r were needed, x was not needed. Off to the races, we're finished. All right, so let's get a little more complicated. So for part B, we're asked to find the cosine of theta. So let's pause for a moment. What do we know about the cosine of theta? Well, by definition, it's x over r. So again, we got to find x and y and r given the information that we have. So what do we have? We are told that the sine of theta is equal to 1/4 and that theta is basically in quad 2. All right, so what do we know about quad 2? Well, in quad 2, we know that y is bigger than 0, and x is less than 0, and of course, r is always bigger than 0. So that's what we know what's happening in quad 2. That's important for what's going to happen next. So what do we know about the sine of theta? Well, by definition, it's y over r, and we're told that that's equal to 1 over 4. So by just a direct correlation, we know that y is 1, and we know that r is 4. All right, and so now I have enough information, right? In order to find cosine, I need that x. So what do we know about a relationship between x, y, and r? Well, we know that x squared plus y squared is equal to r squared, right? So that's the fact that we know. That's the relationship. Of course, you probably also remember it like that. All right, so either way. So all I got to do is plug in what I know to find x. So x squared plus 1 squared is equal to 4 squared. So x squared plus 1 is 16. Subtract 1, x squared is equal to 15. We take a square root. Now we got to be careful here, right? Because remember, when I introduce a square root, I've also introduced a plus or minus. So we have two different possibilities for our x. But this is where this information is important, right? What do we know about our angle? It's in quad 2. And in quad 2, what do we know about our x's? our x's are negative. So this means the x we're looking for is negative square root of 15. So now I have everything. I can go all the way back to the beginning. Oops. Sorry about that. What's the cosine of the angle we're looking for? What's my x-coordinate, which is negative square roots of 15, all over my r-coordinate, which is 4. So there we have it. All right. So for this situation, when the sine is 1/4 and theta is sitting in quad 2, the cosine of that angle has to be negative square root of 15 over 4. All right. And so that's pretty much the going rate on these problems. So we have an XYR definition. There should be enough information to find 2 of the values, and then we use that information to find the third one, and then it's off to the races we go. Real quick, before I do another example, note that, like I said in the last section, we still actually don't know what the angle is. All right, so that's, that is going to come later. All I can do is maybe draw a picture of what's going on. So this angle, right, theta, we know that its y-coordinate is 1, and the square root of 15 is really close to 4. Right, so that angle probably looks roughly like that. So that's about all I can really say with regard to the theta. So I know it's in quad 2. It looks like it's really close to 180 degrees. All right, but that's all I can really say. All right, how to actually find out that theta will come later. We're looking at the trig function values, which means we're not really worried about the input. We're worried about what the output is, right? What's the ratio that comes up? So be aware of that. That's a little tricky, all right? So moving forward, we have the tangent of beta, right? That's what we're asked to find. So how about we pause for a moment. For any angle, what's the tangent? Well, it's the y-coordinate over the x-coordinate. What do we know? We know that the sine of beta is negative 1 over 5. So by definition, sine is supposed to be y over r. Now remember, r is always positive, so this basically says that y is negative 1 and r is equal to 5, right? And beta, sorry, it didn't really come out right, is in quad 3. So what do we know about quad 3? Well, we know that y is negative, r is going to always be positive, and we know that x is negative. So we've got to go find that x. How do we find it? Use the same thing we did above, right? There's our relationship between x, y, and r. We plug in what I know, do some math, subtract 1 from both sides, we get x squared equals the square root of 24. Of course, I'm going to introduce a square root, which means I introduced a plus minus. We're looking for the negative root, so we have negative, and then 24 is 4 times 6. So we have negative 2 square roots of 6. So there's our x-coordinate. And so I can come back over here, right? What's my tangent of beta? Well, it's my y value, negative 1, over my x value, negative 2 square root of 6. All right? And we're not done there, all right? Because that now needs to be simplified. The first thing I got is a negative divided by a negative is a positive. All right? And then the second thing is we need to clear that radical out. So I'll multiply both upstairs and downstairs by the square root of 6. So we end up getting the square root of 6 upstairs, and then 2, that'll be times 6 downstairs. So when all is said and done, right, the tangent of beta is equal to the square root of 6 over 12. All right, and so you can see a lot of our review elements coming into play with that simple little problem. Right, and I just realized I printed this out and left some stuff on the other page. Okay, so there you go. So again, the idea, there's enough information to find x, y, and r. We use that to find our other value. We use the information to figure out am I positive, am I negative, and then we just plug it into the definition. Alrighty. So one last one. The next one's asking us a pretty difficult thing, right? We're not asked to find just one. We want to know all the trig values. All right. So all of them are into play. So let's just go ahead and find our x, y, r first, and then we'll go to town. So what do we know about our angle alpha? Right. Well, first of all, we know that the angle alpha is in quad 4. So what do I know about quad 4? What's going on in that quadrant? Well, in that quadrant, we know that x is positive, y is negative, and of course r is always positive no matter what. All right. What also we know that the secant of alpha under any condition, right, is r over x. Apologize for that. All right, and in this case, it's 2 over 1. So right away, I know my x is equal to 1. It's positive, so we're good. My r is equal to 2, right? And all that's left is, well, what's my y? All right, and so again, we'll come to my formula for x, y, and r. Plug in what I know. Do some solution. Oops, I'm getting ahead of myself. That's a 3. Take a square root. And of course, I introduced a plus minus. What do we want? Well, in this quadrant, quad 4, y is negative. So the y we want is negative square roots of 3. All right, and so I know my x, I know my r, I know my y. We're ready. So the sine of my alpha is y over r. So in this case, it's negative square root of 3 over 2. Right? We know that the cosine of my theta is x over r, right? And so that's going to be 1 over 2. And we know that the tangent of alpha, right, is going to be y over x. And in this case, that'll be negative square roots of 3 over 1, which is basically negative square roots of 3. And of course, the rest of them, how about I just use the idea, well, we're using definitions, right? So the cosecant of theta is defined to be r over y. So that would be negative 2 over the square root of 3. And of course, I would have to simplify that. All right, the secant of theta was already given. It was 2. And then the tangent of alpha, is, the cotangent. The cotangent of alpha is defined to be x over y. And so in this case, it'd be 1 over negative square root of 3. And if we rationalize, the cotangent of alpha would be negative square root of 3 over 3. All right, and so again, there's your probably the most straightforward thing. We're going to get a little bit more abstract in some other videos coming up, but I'll get into that when we get into those other videos. Talk to you guys later.